0.
0.577.
0.577, keep going. 1.
Dash.
Negative 1.73.
Negative 1.
Negative
1.
Back to 1. Not back to 0? At pi?
0.
I looked down. Wait.
Change, somebody type in change to 0. Or change to
Let
pi.
them in.
No, that's right. I think we just.
Okay. Keep going.
Then it's 0.577. Then it's
0.577. Then 1. 0.73. Dash.
Negative 1.73.
I'm just going to look it over there. Huh. So it really kind of repeats. I should have put pi back up here. Should I do that? Pi 0.
Now we're like 3/4 of the way down where we're at.
Okay. So I'm going to get caught up to you, but that's all right. Turn to page 3. Trey, show me where we are on page 3. Or graph 3. So we had 0, and then 0.577, and then 1, and then 1.73, just like right there, and then dash, whatever that means. And then at 2 pi, hold on, what am I doing wrong here? Pi over 2, that's the dash. I'm just going to put a, also it doesn't ask for it. All right, 2 pi over 3, we're at negative 1.7, which is all the way down there. 3 pi over 4, we're at negative 1. 5 pi over 6, negative 7. All right. So if I walk around, I should see something like this, right? All right, so then y'all keep start graphing that next set. If you haven't already, ooh, I like it. You already grabbed it. You have the next one too. Okay, nice. It seems to me this next set just kind of repeats, right? 7 pi over 6, 0.577. So around there. 5 pi over 4 is at 1. 4 pi over 3, 1 point. 3 pi over 2, that's the dash. Then negative 3, negative 1. And 2 pi over 0. Alright, that definitely does not look like sine and cosine. Good. Alright, so next we're going to do is we're going to connect these with a smooth curve. This one's kind of funky, kind of comes there and then kind of goes up like this. So those values that y'all are hitting as errors undefined, those are asymptotes. What we find with the tangent graph is actually it gets closer and closer to that to infinity here as we get closer to those x values. All right. So there's tangent. What does it look like? Yesterday we talked about these graphs that we're looking at now. They repeat. They're periodic. Okay. For sine and cosine, it repeated every 2 pi radians. what does it look like the period is here on tangent? Does it repeat every 2 pi?
It's almost like it's inverse.
Okay, what do you mean by that?
So like you go from the 1.73 to the negative 1.73.
It does flip, yeah. So I would say it's not like it's, yeah. So it hasn't, it doesn't repeat in this little region right here. It doesn't repeat after pi over 2. I'm looking here at 0 and it kind of goes up and then it kind of does this thing here and then it kind of comes up again. And yeah, it's going to go in, it's going to rise up here. It does repeat every 2 pi. However, it repeats even sooner than that.
Every pi.
It repeats every pi. Consider this. Starts off at 0, rises up towards infinity. Starts off at negative infinity, kind of rises up, and then hits 0. And then we're back to where we started from, because it's going to rise up towards infinity, and then hit this asymptote, and then start from negative infinity, rise up to 0. So with tangent actually repeats every pi radian. Period is pi. And we need to know some major points as it relates to the tangent graph. That's where it starts. It starts at 0. After pi, it's also at 0. Right in the middle between those, you've got your asymptote. Then in between those two, in between the starting point and the asymptote, is where it hits 1. And then in between the asymptote and the end point here is where it hits negative 1. So starts as the baseline, ends at the baseline, so to speak. All right. In the middle, there's an asymptote. We go high and hit 1. We go low and we hit negative 1. Okay. So on your cheat sheet for tangent, there's pi, there's 2 pi. The way that I would recommend that you have tangent memorized is you draw a dot there at 0, draw a dot there at pi, right in the middle at pi over 2, draw your asymptote. In between those two at 1, you put a dot, and in between these two at negative 1, you put a dot. Go up here, we go down here. And then you just repeat that whole process. Beginning point, end point on the baseline. In the middle you've got an asymptote. You go high. You go low. That's how I recommend you take care of it. So I'll show you like, this one here. This is, I'm going to give you a quiz probably next Monday or Tuesday, and I'm literally going to give you a blank, this same piece of paper, and you're going to have to plot the graphs. You're lucky because yesterday we only talked about these two, but today we'll talk about all 4 of those. Okay? So our goal by the end of today is to have tangent, cotangent, secant, and cosecant. All right, everybody ready for the next one? Do y'all remember your the angles that you had yesterday? Let's just use those same angles. That way you can watch what everybody else did. I imagine you didn't watch the video, did you? Okay, so let's pick. What's the next one on your chart there? Cosecant. All right. So plug in your numbers for cosecant. Now, remind me, class, what is cosecant? There's not a cosecant button on your calculator. 1 over sine. So everyone calculate what the cosecant is of your angle. we got? You get error? Yeah, you're gonna get error on some of them. Yeah, that's okay. Yeah. Because, let's think back, class. When we had sine, did we ever have 0? Did the sine graph ever cross 0? What does that sine graph look like? Start at the baseline, middle baseline, at first go high, then go low, like that, right? Was the sine graph ever 0? All the time, right?
Yeah.
Beginning, end, right in the middle, it was 0. So here's my question. What happens when you divide by 0? What's that? Nope, it's not 0.
It's not a number.
It's not a number. It's undefined. So if I were to guess, I would guess that whoever had 0, which is probably Trey, right? You got undefined, right? I would guess whoever had pi, that's probably you, Nayeli. You probably had undefined, right? And whoever was 2 pi, who was that? Did you also get undefined? Yep. I bet we can come up with some other pretty interesting stuff here. Does anybody remember what the high point was on the sine graph? I hear that it's 1. Alright, if cosecant, so let's up here class, if cosecant is 1 over sine, so this occurred at pi over 2. So pi over 2, what is 1 over 1? 1. So who had pi over 2? Did you get 1?
Or right now?
Right now, yeah. You got 1? There's another kind of interesting situation that occurs at 3 pi over 2. Y'all remember? What was the lowest value that the sine graph hit? -1. And if cosecant is 1 over sine, then that would be 1 over -1. Well, what's 1 over -1, class? -1. So I were to guess, who had 3 pi over 2? It is -1. How about that? Pretty interesting. This analysis will come in handy here in a second. But in the meantime, let's give me some numbers. Pi over 6. 2? Yeah.
Okay.
Well, yeah, because because remember, sine at pi over 6 was 1/2, and cosecant is 1 over sine. What is 1 divided by 1/2? 2. 1 divided. How many halves are there in 1? Well, there's 2 halves. Yep. Okay. 1.41. Pi over 3. 1 point. Say again. 1.5. 7. Okay. Yeah, you understand the point.
1.1547.
Oh, 1.15? We have validation on that?
1.1547.
547. Okay. Okay, let's see what happens. What about 2 pi over 3?
The same number as 60.
1.54? 3 pi over 4?
1.414.
5 pi over 6?
2.
Well, I'm definitely seeing a pattern there.
Yep.
Huh, I wonder. Okay. 7 pi over 6. -2. Alright, keep going.
-1.41.
Ooh, that's interesting. Keep going. 4 pi over 3.
Undefined?
Possibly. But that's not following a pattern here. 4 pi over 3.
Yeah.
Try. Are you sure it's not -1.15? Let me look at. Let me see what's going on with your calculator. You did inverse sine. It needs to be 1 divided by. Good point. Y'all heads up. Right. Remember, inverse sine is not the same as 1 over sine. Now that's weird because almost all the other times if you have x to the negative 1, it does equal 1 over x. But inverse sine here actually means I give you the ratio, you tell me the angle. I don't know if that, anyway, it's not, cosecant is not inverse sine. If you're going to do cosecant, it has to be 1 over sine. Okay. So yeah, problem solved. 5, 5, and 3.
Oh, negative 1.
1.154. Yep. 7, 5, or 4?
Negative 1.4.
Definitely. And 11, 5, or 6?
Negative 6.
Huh. So all these guys are all negative of what those were. Y'all see how that's interesting how the chart worked out. Let's start graphing. Alright, so 0, I'm undefined. I've got a feeling that that might be an asymptote. Pi over 6, we are at 2, which is actually all the way up there. Okay. 11 pi over 4, so that's here 1.41, so something a little bit below the 1.5 mark. Pi over 3, 1.1, and then at pi over 2, I'm at 1. This is strange. 2 pi over 3, I'm back up to the 1.1. 3 pi over 4, that's the one tick mark over that's not labeled. That's the 1.4. And then at pi, I'm back up to 2. Okay. Those of you that took algebra 2, what does that look like? It does look like a parabola. It's not. But it does kind of look like a parabola. Alright. Oh, nope, I was wrong.
Yeah.
I got off.
It's 5, 5 over 6 that we have 2.
Yes. So this one right here, the 3 pi over 4. Because pi is the undefined. It's another asymptote. I'll just spoiler there for you. Okay. Oh, it's not sine. This is cosecant. All right. So 7 pi over 6, we're at negative 2. Then 5 pi over 4, that's one tick mark over. It's not labeled 1.4. So then this right here, negative 1. 3 pi over 2, we're at negative 1. And 5 pi over 3, we're at negative 1.1. One tick mark over, it's unlabeled. 7 pi over 4 is the 1.41. 11 pi over 6, we're at 2, and at 2 pi. We've got the asymptote. Huh. Well, that's not too bad. You guys should kind of see what's going on there. Still, yeah. So you definitely have to draw the asymptotes. The asymptotes are part of it. And so now we'll connect these with a nice curve. You can draw, I mean, it's meant to be like a parabola, but it's not a parabola because parabola is formed by x squared. Okay. What does it look like the period is of cosecant, class? Say it again? 1 pi? You might think so, because it definitely looks like it's repeating, but it's repeated and it's flipped. So that doesn't count as repeating. It actually has to go through all of this in positive territory, hit the asymptote, all of this through negative territory, and then it would do it again. It would go all that in positive territory, then all that in negative territory. So the period here is actually 2 pi. It's the same as the sign. Now I'm going to test your memory here. Okay? Does anybody remember what the sine graph looked like? Maybe you can look at your chart there, whatever. Where does sine begin? Begins at 0. So I'm actually with a different color, I'm going to put a 0 right there. Where does sine end? 2 pi, yep, and which is 0. You're all right in your own way. And right in the middle, what is the sine graph look like? Also 0. And which happens at pi, exactly. And then at pi over 2, which is exactly in the middle, it's 1. And then in between, over here, 3 pi over 2, it's negative 1. Okay? So, watch this.
Wow.
That's the sine graph, okay? And if you think about it, since cosecant is 1 over sine, when I have 1 over 0, we said that's undefined. You've got an asymptote. So asymptote, asymptote, asymptote. When you have 1 over 1, you're at 1. And then when you're at 1 over negative 1, you're at negative 1. And in case you're familiar with this, as your numerator gets smaller, or sorry, as your denominator gets smaller, your fraction gets bigger. 1 over 0.5, 1 over 0.1, 1 over 0.01 is actually 2, 200, 2,000, 2 million. It gets higher and higher. And that happens over here as well. As your denominator gets smaller, the ratio gets bigger, and that occurs over here in the negative territory. So, what that means is it's actually really good news for us. If you can graph sine, then you can graph cosecant. You're like, whoa, what do you mean? Let me show you. Let's all graph sine since we're all super experts at sine here. Sine begins, baseline, ends, baseline begins at 0, ends at 0, in the middle at 0. So whenever I'm graphing cosecant, I never graph cosecant. I always just graph sine. Start at 0, at 2 pi, it ends at 0, and in the middle, I'm also at 0. And then I know that we go high at the pi over 2, and I know that we go low at the 3 pi over 2, and I draw that graph. Then I come in and I say, all right, now I'm ready for cosecant. Well, cosecant is 1 over sine. So at 0, I've got an asymptote. Pi, I've got an asymptote. 2 pi, I've got an asymptote. Right up here, I know that we're opening upward. And over here, I know we're opening downward. So it's really not so much memorizing 6 things as much as it is memorizing like 2 or 3 things with some extra stuff added on to it. But on that quiz that you'll take, probably next Monday or Tuesday, probably Tuesday since everybody gets Monday quizzes, if you draw the sine curve on the cosecant, I'm fine with that. Okay? Because that's what I would do, and then I'd erase it if the teacher said you can't do it. All right? But that's what I'm going to do. That's what I would recommend that you do. Okay? I wonder if secant has a similar thing going on with it. Probably. Go ahead and calculate your numbers for secant. And by the way, remembering that secant is what class? 1 over cosine. We should end up with a lot of the similar, a lot of similar numbers as we did with sine, but it's not going to be the same location. Okay. All right, help me out, class here. 0, 5 or 6, 5 or 4, 5 or 3. 5 or 2? Okay, so that's fine. 2 5 or 3? 3 5 or 4?
Oh. Wait, is that me?
I'm gonna make a guess.
1.1.
1.41? 1.41 or 1.14? Okay, 1.4, yeah, that's for 2.
No, ours
Isn't it negative?
Yeah, negative, sorry. Yeah,
They're both negative.
Negative 1 point.
That's negative and that's negative?
Yeah.
Oh, okay. And then is this one negative 1.154? Okay. Pi? 7 5 or 6?
Negative 1.4.
4 5 or 3?
Negative 2.
3 5 or 2? Is it 0? I don't think it's 0. I don't think it's 0. Cosine 3 5 or 2 is 0. Undefined. Yep. Oh, that's fine. Well, I'm doing that more based on just on comparing these charts here. 7 5 or 4?
Negative 1 or 1.1.
11 5 or 6?
1, 5, 1,
And 2 pi.
1.
Alright. What do y'all thought we kind of speed this up a little bit, shall we? Let's speed this up. I've got at 0, I'm at 1. I got that one. Pi over 2, I'm undefined. We can do some of these, like the pi over 3, we're at 2. So that's like this right here. 2 pi over 3, we're at negative 2. At pi, we're at negative 1. Four pi over 3, negative 2. 3 pi over 2. Asymptote. 5 pi over 3. We're at 2. 2 pi. We're at 1. These other points, they're just kind of like, they're kind of in the middle. I think that might be enough for us. We kind of have a feel for it now. I think it should be kind of maybe opening upward right there. This kind of looks like it's opening downward. This one kind of looks like it's opening upward. So your asymptotes, let's see how well we remember our cosine graph. If you need to glance at your cheat sheet over there, you can. Where does cosine start, class? Starts off at 1. So it starts off high. Where does it end? At 1. So at 2 pi, it's also over there at 1. What about right in the middle? Negative 1. And then we know that in between the high and the low, it crosses the x-axis, and in between the low and the high, it crosses the x-axis again. So the cosine graph looks like that. And we can see, once again, things, whenever the cosine graph hits its peak, that's where the secant opens upward. Whenever the cosine graph hits its lowest low, bottom of the barrel right down here, then that's when the secant graph opens downward. We can see where the cosine graph crosses the x-axis, that's where you've got asymptotes. Now that you've got the paper, Dalton, I recommend you watch the video. This will make a lot more sense. So, if you pull out your chart over there, for your quick reference, whenever I have to graph secant, I don't graph secant, I graph cosine. I know cosine starts high. At 2 pi, it ends high. And by high, I mean 1. And at pi, I know it hits its low point. Starts high, ends high, in the middle it's low. In the first quarter, it crosses the x-axis. Third quarter, crosses the x-axis. I draw a nice smooth curve for cosine. Starts high, ends high, middle it's low, crosses the x-axis. Then, since I'm drawing secant, every time I cross the x-axis, I've got an asymptote. So I've got an asymptote here. I've got an asymptote here because 1 divided by 0 is undefined. At the peak, I open upward. At the trough, I open downward. And that's how I remember the cosine. Or I remember the secant. All right, look around, seeing some good stuff. Are you ready for the last one? So much. All right, cotangent. Remember, class, cotangent is equal to 1 over tangent. You will have, once again, some undefined values here. That's okay. It's completely normal. Give you a minute to calculate your value.
That was a little disturbing.
Alright, who's got 0? Error, undefined. 5 or 6? 1.73? Okay. 5 or 4? 5 or 3? 0.577. Got it. 5 or 2?
Undefined.
Undefined again.
Negative 0.57.
Negative 1.
5 or 6?
Negative 1.73.
And back to pi. Undefined. 7, 5 or 6? 5, 5 or 4? 4, 5 or 3?
0.577.
3, 5 or 2? Man, you got lucky on these. 5, 5 or 3? 7, 5 or 3? Or sorry, 7, 5 or 4? 11, 5 or 6? And 2, 5?
Undefined.
Alright. So y equals cotangent, which is 1 over tangent. So to start off, I'm going to draw my undefined lines real quick since that's hopefully lengthy. So undefined at 0, undefined at pi over 2, undefined at pi, undefined at 3 pi over 2, undefined at 2 pi. I don't think that's right. Two of you are not correct. There's not that many undefineds.
Those are 0. Is pi over 2 and 3 pi over 2 supposed to be 0?
Someone's 0, yeah. Well, okay. I think it's the I think it's the pi over 2 one. What happened? I need everybody to try this. What is
It
One
shows
is
up as undefined.
over tangent of pi over 2?
It shows up as undefined.
It's saying undefined on the calculator.
Yeah, this is jumping.
What's tangent of pi over 2?
It's undefined.
Tangent of pi over 2 is no. Well, tangent of pi over 2 is
Error. It says on this. It says error.
That's 1 over 1 over 0, so it would be 0.
okay. Hold on. It's
Because tangent of pi over 2 is 1 over 0.
okay. Hold on a second. Tangent of pi over 2. Okay. Tangent of pi over 2 is 1 over 0. How did you figure that out though?
Because on the whatever circle, the y is 1 and the x is 0 for
Yep.
pi over 2.
Let me get you all caught up to speed on what's going on here. Your calculator, if you type this in, like those of you that have the pi over 2 and the 3 pi over 2, if you type it in, it's going to give you undefined. And once again, your calculator has failed you. All right, calculator is not the best tool on this one. Okay, because I mean calculator's right after a fashion. Pi over 2, tangent of pi over 2 is undefined. Okay, but cotangent is really 1 over tangent, And tangent of pi over 2 is really 1 over 0, okay? So, and you can say, well, how do you get the 1 over 0? Because tangent is the y over the x. Y'all agree? You all agree on that? So, if you look at this, you're like, oh, that's undefined. Yes, but there's another way that we can think about cotangent. Cotangent of pi over 2 is just the x over the y at that location. Okay? It's just the reciprocal of that. If you look at pi over 2, which is 90 degrees, okay, the x is 0 and the y is 1. And 0 divided by 1 is 0. And the same thing is true for the 3 pi over 2. It's if you define cotangent as x over y, then it's just going to be 0 over negative 1, which is 0. So, if you don't have a pen, pi over 2 we're at 0, 3 pi over 2 we're at 0. And here's the big picture, since we're kind of running out of time. We're positive to the left of it, and we're negative to the right of it. So we're positive coming down, and then we're negative after that. Same thing here. Positive, so after the asymptote, we've got positive values, then we have negative values. Positive values and negative values. What we're most interested in is this positive 1 and negative 1, which occur actually right in between those points. If you ask me, cotangent looks a lot prettier than tangent. It looks nice within the boundaries. We've got a minute and a half. Let's sketch it on the cheat sheet, and we'll be done with it. So here's cotangent, folks. It actually repeats everything. Look at that. Look at that period. What's that period right there? Pi. So at 0, there's an asymptote. At pi, there's an asymptote. Right in between, it's 0. In between those, so at the corner mark, pi over 4, it's at 1. At the 3/4 mark, it's at negative 1. It kind of slides like that. Then we're just going to repeat. Asymptote at pi, asymptote at 2 pi. Right in the middle, we're on the baseline, we're on that x-axis. During the first quarter, we're positive. During the third quarter, we're negative. You think kind of looks like a cubic, but not quite. There we go. Today, we did 4 of them: cosecant, secant, tangent, and cotangent. Okay. We also learned some tricks for how to graph those. You are going to have all those memorized. I recommend that you start sketching them. Tomorrow